Hello, in this lecture, we are going to discuss a counting problem, counting how many line segments are there in this picture. Before we discuss, let's first do a warm-up problem. Today is October 22nd. We know that in October there are 30 days. So the question is from 22nd to the end of the month, 30th. Count how many days are there. Okay, this is a very simple counting problem. By now you should have answers. What is the answer? The answer is 9 days. I hope you didn't answer 8 because 30 minus 22 is 8, but that's not the amount of days we have because the amount of days is actually one more. And the 9 days are 22nd, 23rd, and you can count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. This problem shows that counting problems, even though sometimes are very simple, but it's very easy to make a mistake. And when we do counting problems, we have to be very organized. So now we can start. Okay, so how many line segments are there? We're going to discuss several ways to count it. The important thing, of course, is always be organized in counting. So first, we need to be careful. It's not only 5 segments we're talking about, because when you say 5 segments, these are just 5 segments of length 1. And they are segments of different lengths. So one way to count organized way is to count segments of different lengths. So after we count 5 segments of length 1, we'll count segments of length 2. And we'll ask ourselves how many segments are there of length 2. Okay, so let me write down the segments of length 1, which from left to right will be A, B, B, C, C, D, D, E, and finally E, F, right? E, F, D. And the segments of length 2 are from left to right, you have AC, and next you have BD, and then starting from C. Now from C you have 2 segments you can make with length 2, CA and C. But since we're counting from left to right, the CA is actually already accounted for, which is the same as AC. So you only need to worry about going from left to right, C to E, and don't need to worry about C to A. And finally, we have DF. So total 4 segments of length 2. And it is also easy to count segments of length 3. And we can see there's a pattern here. There will be 3 segments, which are from left to right, AD, BE, and CF. Many times being able to find the pattern will help us in counting. Okay? And the next time for length 4, the pattern says we have 2 segments. Even without writing them down, you should know there are two, from A to E and from B to F. And finally, there will be one single segment from A to F. Last one. So now we are able to add up, and the total will be 1 plus 2 plus 3 plus 4 plus 5. Ah, but this is actually some addings that we know how to do it in an easy way because there is a pattern here. It's arithmetic sequence. And when you add arithmetic sequence, there's a little trick here, namely you double it and you have a bunch of sixes. And that will be 30 because 5 times 6, and then you divide by 2 because you double it. So total answer will be 15. Okay, so we finish this problem, but we're not done yet. We are going to give some other ways to count. And sometimes other ways might be interesting also because they give you new ideas of how to do the count.